Okay, now here's where the technique changes. And every time I give a test on this, students tend to mess this up. Not every student, but a lot of students tend to mess this up. So this is another one of the videos I'll probably end up posting before the exam so you can take a look at it again. Because I want you guys to get this right. And it's actually not that hard. It's just if you don't review it before the exam, you're not going to remember it. It's a cubed root this time, right? So let's examine that property we talked about a couple minutes ago. If you take the square root of a times itself, you do get just a, right? Is it still true if you take the cubed root of a times the cubed root of a? Do you still get, whoops. Do you still get a? Question mark. No, you actually get the cubed root of a squared, which is in simplified form. You can't do anything with that. Well, so the technique then would be to multiply numerator, denominator. Well, okay, let's not even talk about this problem. The technique, if you had the cubed root of just a, and you wanted to multiply it by something to get rid of the radical, the technique would be to multiply by something so that you get the cubed root of a cubed, right? It's really the property, this property that we want to use, the nth root of a to the n equals a, right? So what would you multiply the a by, just thinking in terms of the radicand, what would you multiply the a by to get an a, in this case we need an a cubed, so that the cubed root of a cubed, n is 3 in other words, the cubed root of a cubed is equal to a. That's what we want. What would you have to multiply by? What would the radicand be? A squared. And then you'd have the cubed root of a cubed when you did the multiplication, which is equal to a. And it's really taking advantage of the property, the nth root of a to the n is equal to a. The reason it worked for square roots is because, oh yeah, n is 2 in that case, and the square root of a squared is equal to a. But in other cases, you can't just multiply by the same radical and expect something good to happen. You have to think about it a little bit. Okay, so now let's go to this problem. I'm going to use the technique where I split up the radical. So that's going to make it the cubed root of 7x on top over the cubed root of 4y on the bottom. And if you wanted to, if it helps, you can factor that 4 into 2 squared, if it helps. So 4 is 2 squared, right? That's all I did there was replace the 4 with 2 squared and break up the radical. Okay. So what I want, in order to get that radical to disappear in the denominator, I want perfect third powers on each factor. So I would multiply numerator and denominator. Okay, let's just think about the denominator. It's got to be a cubed root, right? Cubed root over a cubed root. Okay, so what do I multiply 2 squared by to get it to be 2 cubed? Just 2 to the first power 2. What do I multiply y by to get it to be y cubed? Y squared. And I've got to do the same thing on the top, right? So I'm going to multiply numerator and denominator by the cubed root of 2y squared. Does everybody understand? Are you with me? Does that make sense? Okay, now let's analyze this and make sure you understand. First of all, on top, there's not a whole lot to think about. Just make one big radical, one big cubed root, multiply the radicands. What do we get? 7x times 2y squared. What does that turn out to be? (7x times 2y squared). 14xy squared. So that's underneath the radical. So on top, it'll be the cubed root of 14xy squared. On the bottom, we're not going to simplify yet. What should it be? It'll be the cubed root of, okay, what's 2 squared times 2? Right, which is 2 cubed. What's y times y squared? It better be y cubed by design. So now look. When you take the cubed root, you can do it individually if you want, right? When you take the cubed root, you get a 2 and a y. Is there anything left underneath the radical other than 1? No, so you don't write it down. The cubed root of 1 is 1. So you've done it. You've done it. You get on top the cubed root 14xy squared. On the bottom, you get the 2 the y, and then the cubed root of 1 is just 1, so you don't write it down. What's your question?
Well, why is that 2y?
On the bottom?
Yeah.
Okay, let's look at that. Okay, here's what you're used to doing, at least since yesterday. If you simplify this radical, guys, this is a good question. If you simplify this radical, we know that we can pull out the cubed root of 2 cubed, right? Okay, so what's the cubed root of 2 cubed? That's 2, right? What's the cubed root of y cubed? Y. What's left underneath the radical? Well, you don't write it down usually, but it's a 1, right? When you factor everything out, what's left? A 1, always. What's the cubed root of 1? 1. What's 2y times 1? 2y. Okay, well, let's try it again. If you didn't understand that round, I've got another round for you. So this time it's a fifth root. In part D, let's simplify, or let's rationalize the denominator. In part D, the fifth root of 7 divided by 32x to the fifth y. Okay, first of all, I would simplify it as much as possible in the way we described yesterday, simplifying radicals. Let's break up the radical and make it the fifth root. Whoops, let me change colors. Let's break up the radical and make it the fifth root of 7 on top, and then the fifth root of 32x to the fifth y on the bottom. Now, do you notice anything about a couple of the factors in the denominator, in the radicand in the denominator? What about 32? How does that break down? Yeah, the 32 is 2 to the fifth, right? So 32 is a perfect fifth power. What's the fifth root of 32 then? 2. So before you do anything, before you try to get rid of the radical, simplify it. The fifth root of 32 is 2, so you can bring a factor of 2 on the outside. What about the fifth root of x to the fifth? X. So bring that to the outside as well. And then let's rewrite it. Let's go over here and rewrite it. The fifth root of 7 is still on top. On the bottom, we have 2x times the fifth root of just y, which is a little easier on the eyes as far as the radical goes, or the radicand goes, right? Okay, so now this is, if you understand this, you got it. So pay close attention. We want to get rid of the radical in the denominator, right? So if I wanted to get, what would be nice to have as an exponent on the y? What would be nice to have in that box? It would be nice if we had a 5 there. Then the fifth root of y to the fifth would just be y, and the radical would disappear. That's not what we have, though, is it? But wouldn't it be nice? Then you'd be done. Okay, you can make that happen by multiplying numerator and denominator by the correct thing. What would I have to multiply y by to make it y to the fifth? Y to the fourth. So you have to multiply numerator and denominator by, okay, it's got to be a fifth root. And it's got to be y to the fourth underneath the radical. Okay, does everybody understand that logic? First of all, what are we really multiplying by, the entire fraction by? 1. So we're not changing the value of anything. That's really important. And then in the denominator, you can see the fifth root of y times the fifth root of y to the fourth should be the fifth root of y to the fifth, which is just y. And I'm going to show that step. So we get, on top, what do we get? Just one big fifth root of what? 7y to the fourth. We cannot simplify that any further than it's already simplified because you have no perfect fifth power factors in that radicand. So we're done there. Then on the bottom we have the 2, we're multiplying straight across. 2x, and then the fifth root of y times the fifth root of y to the fourth. You multiply them together. I'm going to show an intermediate step here. You multiply this guy times this guy underneath the radical, right? So that should help show you that you're going to get y to the fifth underneath the radical, just like we want. And so that's not normally a step I would show, but I just want to help you understand. So then you'd get the fifth root of 7y to the fourth divided by 2x times the fifth root. Whoops, that's a horrible looking 5. Times the fifth root of y to the fifth. And then the fifth root of y to the fifth is just y, and the radical goes away. Okay, so I'm going to show another step here. Well, actually, there's nothing else to show. This will be the last one. Fifth root, 7y to the fourth over 2x, just y, right? Because this guy right here, fifth root of y to the fifth, is y. Okay. Did that make it clearer? Less clear? What do you think? Okay, now it's really important you go home and practice these as soon as you can, because your memory will fade over a couple days if you wait.